Hi. So today, we're gonna talk about AI agent and workflow. What's the difference about that? So I'm gonna introduce my professor Henry Chang, and he provide a whole bunch of references. So I'm gonna just talking about that because it's some kinds of security problem, I think. So anyway, let's first lesson start it. Generative AI agent, workflow, and agent. What's the difference? So agent can be defined in several ways. Some customers define agents as fully autonomous systems that operate independently over extended periods, using various tools to accomplish complex tasks. Others use the term to describe more prescriptive implementations that follow predefined workflows. And Anthropic categorizes all these variations as agentic systems, but draws an important architectural distinction between workflow and agent. So, workflow and agent. So there's two aspects, and okay, let's go talking about definition. So workflows are systems where LLMs and tools are orchestrated through predefined code paths. And agents are systems where LLMs dynamically direct their own processes and tool usage, maintaining control over how they accomplish tasks. So use cases. So workflows offer predictability and consistency for well-defined tasks. Agents are the better option when flexibility and model-driven decision-making are needed at scale. So, for many applications, however, optimizing single LLM cores with retriever RAG log and in context examples fine-tuning is usually enough. This might mean not building agentic systems at all. So step 1, process of selecting solutions. Step 1, single LLM cores. Step 2, workflow. Step 3, finally, agent. So when and when not to use agents. So when building applications with LLMs, we recommend finding the simplest solution possible, right? So only increasing complexity when needed. This might mean not building agentic system at all. Agentic systems often trade latency and cost for better task performance. Consider when this trade-off makes sense. When to use agents, when more complexity is warranted. Workflows offer predictability and consistency for well-defined tasks. In contrast, agents are the better option when flexibility and model-driven decision-making are needed at scale. For many applications, optimizing single LLM cores with retriever and in-context examples is usually enough. So when and how to use frameworks. So frameworks simplify agentic systems implementation and reduce low-level tasks, but add abstraction that may obscure underlying prompts and responses. They can tempt adding unnecessary complexity when a simpler setup would suffice. So how we're going to use. Step 1. Developers are advised to start by using LLM APIs directly. Many patterns can be implemented in few lines of code. Refer to the cookbook for examples. Step 2. If a framework is used, ensure understanding of the underlying code to avoid customer error. There are many frameworks that make agentic systems easier to implement. LangGraph from LangChain, Amazon Bedrock, AI Agent Framework, Rabbit, a drag-and-drop GUI LLM workflow builder, Volume, another GUI tool for building and testing complex workflow. But I prefer use LangGraph and Bedrock. So building block, the augmented LLM. So I think I don't know how do I say about that without drawing. So there's input and output. There are input and output, and in the middle of that part there is LLM. So in LLM, output, think about like that sequence, and then LLM in that case can be separated three parts: retriever, tools, memory. So in that case, retriever is query, so getting query and sending result. Tools, call and response. Memory, read and write. Again, input to LLM, and LLM there are retriever, tools, memory. Retriever is query and getting result, and tools is calling and getting response, and memory is read it and writing, and then go to output. So the basic building block of agentic systems in an LLM enhanced with augmentation such as retriever, tools, memory. So our current models use these capabilities by generating their own search queries, selecting appropriate tools, determining what information to retain. So this is LLM augmentations, aspects, and description. So how can we implement it? This is focus on two key aspects of the implementation: tailoring these capabilities to your specific use case and ensuring an easy, well-documented interface for your LLM. One approach is using Anthropic's recently released Model Context Protocol (MCP), which allows developers to integrate with a growing ecosystem of third-party tools through a simple client implementation. Okay, so let's talk about workflow. Have you heard about prompt chaining? So prompt chaining is simply getting input and LLM core 1 and output 1 is gonna go to gate, and gate can be separated two sections. One part is pass and another one is fair. So if it's fair, it's exit, but if gonna be passed, LLM core 2 called and output 2 generated, and then core 3 and then going out. So workflow prompt chaining decomposes a task into a sequence of steps. Again, prompt chaining decomposes a task into a sequence of steps. So each LLM core processes the output of the previous one. Add programmatic checks. Gate in the diagram. I cannot show you the diagram, but I'm gonna show you another time again. Okay, so programmatic checks on intermediate steps to ensure the process stays on track. So when to use this workflow? So ideal for situations where the task can be decomposed into fixed subtasks. The main goal is to trade off latency for higher accuracy by making each LLM core an easier task. Second workflow, routing. So input to LLM core router and then separated a lot of routing section, LLM core 1, core 2, core 3, core blah blah blah, core n. Then merges to the going to the output. So routing classifies the input and directs it to a specialized follow-up task. This workflow allows for separation of concerns and building specialized prompts. Without this workflow, optimizing for one kind of input can hurt performance on other inputs. Ideal for complex tasks with distinct categories, classification can be handled by an LLM or a traditional classification model or algorithms. So routing examples, directing different type of customer service queries, general question, refund request, technical support like that, into different downstream processes, prompts, and tools. So routing easy, common questions to smaller models like Cloud 3.5 Haiku, routing hard to unusual questions to more capable models like Cloud 3.5 Sonnet to optimize cost and speed. Okay, workflow 3, parallelization. So, overview, LLMs can work simultaneously on a task. They aggregate their outputs programmatically. So, this workflow is called parallelization. It manifests in two key variations. So, variations is sectioning. Breaks the task into independent subtasks running parallel. And voting. Voting runs the same task multiple times to get diverse output. And parallelization is effective when subtasks can be parallelized for speed. It is useful when multiple perspectives or attempts are needed for higher confidence results. For complex tasks with multiple considerations, separate LLM cores allow focused attention on each aspect. So example, implementing guardrail where one model instance processes user queries while another screens or for inappropriate content or requests. Automating evals for evaluating LLM performance on different aspects. This approach performs better than having the same LLM core handle both guardrails and the core response. So examples, voting. Reviewing a piece of code for vulnerability with several different prompts, flagging the code if a problem is found. So evaluating whether a piece of content is inappropriate with multiple prompts assessing different aspects, using different vote thresholds to balance false positives and negatives. And workflow 4, orchestrate workers. So this one is input, orchestrator, LLM core 1, LLM core 2, LLM core 3, blah 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 blah, and again merge to synthesizer. Orchestrator and synthesizer, then go to output. This is orchestrator workers. So orchestrator workers workflow, a central LLM orchestrator breaks down tasks. It delegates them to worker LLMs and synthesizes their result. When to use? effective for complex tasks where subtasks cannot be predicted. Flexibility differentiated it from parallelization, as subtasks are determined by the orchestrator based on the specific input. So, use cases used for coding products that make complex change to effective to agent, used for search tasks that gather and analyze information from multiple sources. So workflow 5. Okay, evaluator optimizer is some kind of routine. Input LLM code generator, make solution LLM code evaluator, again rejected or to giving a feedback to code generator, and solution evaluator rejected or feedback blah 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 blah, again and again, and then accepted, go out. So one LLM code generates a response. Another LLM provides evaluation and feedback in a loop. Workflow enables iterative refinement, analogous to a human writing process. So effective when clear evaluation criteria exist. Iterative refinement provides measurable value. So LLM responses improve with human feedback. LLM can provide its own feedback. Literally, translation where nuance are better captured by evaluator LLM critics. Complex search tasks with multiple rounds of searching and analysis for comprehensive information, the evaluator decided it further searches are warranted. Okay, now let's talk about agent. So what is agent? So human, LLM code, action, environment, feedback, action, environment, feedback, and stop. What I'm saying is, agents start with a command or discussion with a human. They plan and operate independently. They may request additional information or judgment. They obtain ground truth from the environment at each step. They assess progress and request feedback when needed. Tasks terminate upon completion or predefined conditions. So agents use tools based on environment feedback in a loop. Design of tool sets and documentation is crucial. So handles open-ended problems with unknown steps, operates for multiple turns autonomously, requires trust in its decision making. Higher costs and potential errors due to autonomy. Extensive testing and guardrails are recommended. So, when to use agents? So, agents can be used for open-ended problem where it's difficult or impossible to predict the required number of steps and you cannot hard-code a fixed path. The LLM will potentially operate for many turns and you must have some level of trust in its decision making. Agents' autonomy makes them ideal for scaling tasks in trusted environments. The autonomous nature of agents means higher costs and the potential for compounding errors. We recommend extensive testing in sandboxes experiments along with the appropriate guidelines. So, for example, a coding agent to resolve SWE bench task, which involves edits to many files based on a task description. And another one, Anthropic's computer use reference implementation where cloud use a computer to complete tasks. So, if you want to make high-level flow of coding agents, in that case, make sure you need to make a good query. So humans have to make a query to interface until task clear. So then clarify and refine, and then going to LLM and send the context. And then LLM using environment, search files, write code, test, blah blah things, and then return paths, complete, and then display. Or until tests pass, write code, status, test, result. This is keep going on. So next time I will show you more appropriate images for this architecture. But now I don't want to show you anything. I just want to talk about that because it made from Henry Chang, not me. Yeah. So next one, agents in practice. Overview. Our work with customers has revealed two promising applications for AI agents. Agents add value for tasks requiring both conversation and action. Success criteria, feedback loops, and human oversight are crucial. For example, customer support. Customer support uses chatbot interfaces with tool integration. Support interaction follow a conversation flow. Tools pull customer data and order history. Actions include issuing refunds and updating tickets. Success is measured through user-defined resolutions. Companies use pricing models based on successful resolutions. About coding agent. Software development benefits from LLM features. Capabilities have evolved from code completion to autonomous problem solving. Code solutions are very favored through automated tests. Agents iterate on solutions using test result. Output quality is measured objectively. Human review ensures solutions align with system requirements. So prompt engineering your tools. Tools are an important part of agentic systems. Tools enable cloud to interact with external services and APIs. Tool definitions require prompt engineering attention. So, multiple methods exist for specifying the same action. File edits can be specified using a div or by rewriting the entire file. Structured output can be written in JSON or Markdown. Some formats are harder for an LLM to generate. Writing a div requires knowing the exact line changes. JSON formatting requires extra escaping of new lines and quote. So format selection. Provide the model with enough token to think before writing. Keep the format close to naturally occurring text on the internet. Minimize formatting overhead such as counting lines or escaping strings. Consider human-computer interfaces when designing agent-computer interfaces. Invest effort in optimizing tool usability. Ensure tool descriptions are clear and intuitive. Include example uses, edge cases, and input format requirements. Adjust parameters named to make usage more obvious. Test tools using various inputs to identify mistakes. Modify arguments to reduce potential errors. Use poke-yoke techniques to enforce correct usage. Okay, I'm gonna talk about Poké next time. So practical example, while building an agent for SWE event, more time was spent on tool optimization than prompt engineering. Relative file paths cause error when the agent moved out of the root directory. Requiring absolute file paths resolved the issue and improved performance. But now actually it was changed. Absolute path now. Relative path is working now. Okay. Oh, what happened? What the? Oh. Okay. So the first section lesson is done. Workflow and agent. Yeah. Tomorrow I'm gonna talk about another one, workflow or architecture. I don't know. It's up to me. Anyway, give any comments to improve this lecture. And thank you, Henry Chang. Thank you so much. I love you. Bye. I love you all.